My name is Sally Otto. I'm an evolutionary biologist at the University of British Columbia, where I'm a professor. If you look around at the world that surrounds us, to me it's just so motivating and inspirational. Really, every organism that we look at has secrets inside it to the last 3.5 billion years of its evolution. And so for me, it's like being a detective. And we have all these clues all around us in the world. And to use these clues to puzzle together what must have happened in our evolutionary past. That's what I do, and that's what I find so fascinating. I try and understand how evolution proceeds, to predict the ways in which evolution can and cannot occur. So I use a combination of experiments with yeast or with plants, but mainly I use mathematical models. Math can be really helpful when things are so complicated you can't intuit what the answer would be. So I use models to say, well, if we put all of these ingredients in, which way will the system evolve? Which way will it change? And then if you change the ingredients just a tad, will it evolve in different directions? And by doing that, I can get a better sense of why there's such diversity of organisms in the world around us. First, I should say that not every organism is sexual, but there's a lot of other organisms, plants and various insects and various microbes, that can reproduce asexually. So the question for an evolutionary biologist is, well, why do it this way and not that way? The standard stock biological answer has been for variation. The problem with that answer is that mutation and other forces also generate variation, and you can actually have an asexual cloud of individuals that are quite variable. Math really helps, because we can put these into a mathematical model and then ask, well, does sex increase variation or does it reduce variation? And so that's what my models have been aimed at answering. Right now I'm working on a project with my graduate student where we're asking, why can multiple species coexist in the same spot? Why isn't it just all taken over by some invasive species and there's just one of them there? And so one of the reasons that we found is that if there's really strong mating preferences, that you can actually stably maintain multiple types in one area. So for example, with peacocks, where they have preferences for certain types of mates. Well, if there were two types of peacocks with slightly different preferences, we're figuring out what can keep these multiple populations together and coexist rather than force one of the species to go extinct. I think the MacArthur Fellowship is meant to tell people, look, we want you to be creative. We want you to change your life in the ways that you need to have time to do the stuff that you do well. And so I'm going to take that to heart and try and carve out more time for research, for thinking, for the kind of math that I love doing and the science that I love doing.